is the today's topic. Listen, all of you, it's very important, not only for exam, it is useful for our day-to-day life also. The first application is electric bulb. What is the material used for making this filament? This is the filament of the bulb.
Tungsten.
Tungsten. Tungsten metal is the material used for making this filament. And what are the properties of tungsten? Why tungsten is used for making the filament? What are the properties of tungsten?
Sir, it can be heated to white hot.
Before that, the main property.
Main property.
Tungsten has
Resistivity.
high resistivity and
High
can be
resistivity.
drawn into thin wire.
Its melting point is
Yeah.
3380
Yeah,
Celsius.
high melting point, 3380 degrees
Can be
Celsius.
drawn to wires.
Thin wire. So we can make it very thin. If it is very thin, area cross section is very less, resistance will be very high, isn't it?
Yes, sir.
So here, the resistance of this filament is increased by making it very thin, because we know that the resistance of a wire is inversely proportional to area cross section. And also resistance is increased by making this wire, instead of this filament taking a single wire, it is in the form of a coil, like a spring like, isn't it?
Yes, sir.
So it is a spring like this. Many turns are there, like this, a coil. Because of that, length will be very large. And also we know that resistance is directly proportional to length. If length is more, there will be more resistance. And the material is tungsten, and tungsten has high resistivity also. Because of all these reasons, more length of this tungsten wire and very thin area cross section and high resistivity, this total resistance of this filament is very high. High resistance is there. So what will happen, suppose we are giving electrical connection here. If you are giving these 2 points to the plug, suppose here is the switchboard. In the switchboard, one line is live wire, that is neutral. If you give from live to one and neutral to the other one, what will happen? Current will start flowing from live wire to neutral wire.
Neutral wire.
Yeah, live wire to the neutral wire through this filament.
Yes.
Means once you switch on the circuit, through the live wire, current will enter and it will flow through this metal electrode and through this high resistance filament, tungsten filament. Then it will leave through this one, it will go to the neutral. Got it? During
Yes, sir.
that time, when a current I flows through this filament, suppose a current I is flowing through the filament, because of Joule's heating, Joule's law. What is Joule's law equation? H is equal to heat energy
equal to
produced
I
is equal
square
to heat energy produced is equal to I square RT. Square of the current into resistance,
Yep. Just into time.
yeah, into resistance into time. So because of this high resistance of this filament, it will get heated up to above 3000 degrees Celsius. When it is heated above 3000 degrees Celsius, it will glow with white light. So it will start giving out white light because of the high temperature above 3000 degrees Celsius. Got it?
Yes, sir.
And other important points in the working of the electric bulb, when the filament is glowing with the above 3000 degrees Celsius, and if there is oxygen inside the bulb, that filament can get oxidized into tungsten oxide, that is a gas. Means the filament will be fused. To avoid that, what we are doing?
Nitrogen.
Nitrogen.
Inside the glass bulb, air will be removed.
Yes.
Air is
Then
removed,
Nitrogen.
and
will be-
inert gas like nitrogen or argon. Nitrogen is very inert, it won't react easily. So N2 gas is filled inside at low pressure.
Or every inert gases can be kept.
Yeah, any inert gas can be used, but normally we use nitrogen gas. Nitrogen is also inert, it won't react easily. Nitrogen is filled inside to reduce the evaporation, because when the filament is heated above 3000 degrees Celsius at high temperature, the atoms of tungsten may evaporate, like sublimation. You know sublimation. What is sublimation? The from solid state
to
directly it will go to
gaseous
gaseous
Solid
state.
to gas.
So that will happen, when the temperature of the tungsten is above 3000 degrees Celsius. So the atoms of tungsten will start sublimating, it will go to gaseous state and it will stick on the glass surface over here. And slowly, within few days, the thickness of the filament become very thin and it will break. Means the lifespan of the bulb will be very less. To increase the lifespan, we are filling inside with the nitrogen gas at low pressure. If nitrogen gas is present, we can reduce this evaporation or sublimation of the tungsten filament or the tungsten atoms. Got it?
Yes.
So the
Yes, sir.
working of electric bulb is an application of Joule's heating, and because of the high temperature, the filament is heated up to high temperature and start glowing. So the main disadvantage of this electric bulb is that who invented this one?
Sir, Thomas Alva Edison.
Edison. Edison invented this one. And you remember what was the first experiment done by Edison?
Sir, chicken eggs.
Okay. So when his mother was looking,
yes, sir.
searching for Edison, he was lying inside a court and he was lying on some egg when he was very small boy. And in future he invented this electric bulb, the first lighting device in the history, the first electrical lighting device before we were having kerosene lamp and candles. The first electrical lighting device was invented by Edison, that is incandescent lamp. It is called incandescent lamp. Normally we call electric bulb. Now it is outdated. Now it is used only in poultry farm. The first experiment of Edison was hatching chicken by lying on the egg, and in future he invented this one, original electric bulb, and now this electric bulb is used in poultry farms only because most of the electrical energy in this bulb is used for most of the electrical energy in this bulb is converted to heat energy, and very less amount is coming in the form of light energy. So a huge amount of energy is wasted in the form of heat instead of light. Now it is outdated. We are not using it at home and all. Before we were using this type of bulb. One will be 100 watts or 60 watts. Minimum 40 watts. We have to use in a room minimum 40 watts. It will give very less light only. If you want to get a good light, you have to use 100 watts bulb. Now you can see the LED bulb we are using. It is only 5 watts. The normal LED bulbs we are using is 5 watts. For LED bulb, there is no filament like this. The working of LED bulb is not based on Joule's heating. It is a semiconductor device. It is gallium arsenide semiconductor material. PN junction diode, and it's then the second application is electrical heating devices like iron box, toasters, geyser, water heater. Suppose we take the example of iron box. You can see this is the iron box. This is the heating element of iron box. You can see these two yellow terminals are here. The connections are given from here. And this zigzag lines it is made up of nichrome. Nichrome is the alloy used here. Nichrome. What are the constituent metals in nichrome?
Sir, nickel,
Nickel, chromium,
manganese,
and iron.
Iron.
So when we are switching on an iron box, this heating element, it will be kept between two thick metal plates. Okay, this will be sandwiched. Between two thick metal plates, and the connections will be given here. Suppose we are giving electrical connection to an iron box. Normally we have to use 3-pin plug. For iron box, it is compulsory to use 3-pin plug as a safety measure. So one wire, suppose this is live, this is neutral, and this is the earth wire. From the live wire, from the switchboard, will give one connection to this end, any end. Okay, doesn't matter. You can give this point or this point, any one of the ends. And from neutral to the other side here. And on the metallic body of the iron box, there will be a green wire. That green wire should be given to the thick earth pin, this one. Because if there is any leakage of current in the metallic body, then that current will flow through this green earth wire to the earth. This will be connected to the earth through the earth wire. This is a safety measure. Now when we switch on the circuit, what happens? The current will start flowing from live wire through this heating element. It is zigzag here because it is having very large length, long wire. It is kept in the form of zigzag in between. It is nichrome. So when current flows through this nichrome wire, because of the high resistance, nichrome is an alloy. What are the advantages? What are the important properties of an alloy? Why alloys are used for making heating elements? There are two reasons for that.
Sir, it has more resistivity.
More resistivity. Then Means the resistivity of an alloy will be always more than the resistivity of the constituent metals present in it, isn't it? So because of high resistivity, high raw value, then its length is increased by this, making like this zigzag, like this, length is increased. Then next, one more point is there. When it is heated in contact with air, you see in the bulb, can you heat this bulb in contact with air? Because it is a single metal. Tungsten is a single metal. And when it is heated to high temperature, it will oxidize by reaction with oxygen in the atmosphere. But here, the nichrome, it is an alloy. Alloys will not get oxidized. Alloys will not get oxidized when they are heated in contact with air. Here it is heated in contact with air. We are not keeping any glass bulb. There is no glass bulb here. It is directly in contact with air. So it can be heated in contact with air. It won't get oxidized easily. That is the second advantage. So remember the two reasons for using alloys for making heating element like nichrome. The one reason is it has high resistivity, raw value. So the resistance, what is the equation of resistance? R equal to rho into
L by A.
L by A, rho L by A. So the resistance of this heating element, the resistance of the heating element is made maximum by using the nichrome. It is having high resistivity value, then making it zigzag. Okay, so length is maximum and it will be thin wire, so area cross section will be less, so then also resistance will be high. Because of all this effect, there will be very high resistance for this nichrome wire, and because of that, Joule's heating, H is equal to I square RT. When a current flows from the live wire through this heating element, then it will leave through this neutral wire. That is the normal path of current when you switch on an iron box. And due to that current flowing through this heating element, if I is the current flowing through the heating element, then H is equal to I square RT. Heat energy will be produced. And because of that heat energy, the heating element will get red hot, not white hot. We don't want white hot for ironing purpose, isn't it? Can you iron with white hot 3000 degrees Celsius your dress, your polyester, cotton cloth and all?
Oh, sir.
No, so no, we don't want here white hot. We need only red hot only. Nichrome wire will be heated to red hot, and also above this and below this. Okay, this upper surface and bottom surface, it will be insulated. A strong insulator, good quality mica sheet will be kept above and below. And above that only metal plate, the next metal plate will be placed. So this area, this much part will be strongly insulated from the contact with the other metal parts. Means when current flows through this, current will not come to the outer covering. If there will be an outer covering here like this, another metal plate, in this metal plate current will not reach. Red hot means low temperature. Red hot will be less temperature. White hot means above 3000 degrees Celsius. A metal can be heated to white hot if its temperature become above 3000. And before reaching that temperature, most of the metals will melt. But tungsten is the metal which is having very high melting point. Got it?
Okay.
So you can see the original iron box here. See this? Okay.
Oh, sir.
Okay, this one, an old iron box. If you open this one, this is the heating element. Okay. Actually, it is concealed inside. It is not in contact, and there are two wires here. One connection we can give at this point, another connection this point. Then when we give the electrical connection, switch on the circuit, current will flow through this heating element. Current will flow through this heating element this way, and it will leave through the neutral wire. Okay, and there are some control switch here for controlling the temperature to high temperature and low temperature. For that there is a variable resistor, another one. It will control the current flowing through this heating element. When high current flows, it will heat up more. When less current flows, because I square RT. Okay, by controlling the current we can control the temperature. And when this heating element is heated up, that will be transferred to this metal surface. But this metal surface and this heating element, inside it is insulated. It is not in direct contact. So normally when you switch on this one, if you touch here, you won't get electric shock because there is no current coming here. But there are chances electric current may reach here. In such situation, you can see there is a screw here. On this screw, metallic body. On the metallic body there is a screw. On that metallic screw we have to connect the green wire of the earth wire. And this green wire, one end will be connected here, the other end will be connected to the thick pin of the 3 pin. This is the 3 pin plug. In this you can see 3 pins are there, isn't it? And this is the thick pin. The other end of the green wire should be connected here, and one live wire to this point and neutral wire to the other one. Thick pin is for earth wire. And in the switchboard, this will go to the earth. The earth wire will be finally given to the earth. By digging the earth, you have to keep a long metallic rod inside the earth, and to that metallic rod this will be connected. The other end of this will be connected. So what happens whenever, suppose there are 2 wires here, say this is the live wire, and when we are using the iron box, suppose this live wire, it came in contact with the metal surface, hot metal surface. Okay, by mistake, if it come in contact with the hot metal surface, the insulation will melt and the inner copper wire will come in direct contact with the outer metal surface. If it happens like that, got the point? If the wire is coming in contact with the metal surface, normally it won't happen. By mistake, if it happened, then the wire insulation will be melted, the inner copper will come in contact with the outer metal surface. That time if you touch here, you will get electric shock. Normally if electricity is passing through our body, 2 things are happening. The 2 things happening in our body when electricity is passing through our bodies, first thing is that our muscles will contract suddenly. So if you are touching like this, and if there is electricity, suddenly, okay, it is involuntary, not voluntary, without your permission, suddenly your muscles will contract and you will have a strong grip on this. You cannot release that, and the person will die, because all muscles will shrink if current passes through the muscles. Our heart is working like that. In the heart, when the pulse maker produces some pulse of electricity, and when it passes through the muscle fibers of the heart contract like this. Then when the pulse is over, it will relax. Again pulse comes, it contracts. So all muscles are contracting, all muscles will contract when electricity passes through it. So that will happen for your hand also. So if there is a doubt, suppose you have some doubt, there is chance for electricity on this surface. In such time, you don't touch like this. In such situation, if you have a doubt that there can be electricity in that area, in such situation you don't touch like this. You touch from the back side only, like this only. If you touch like this, your muscles will not contract this way. Muscles can contract only this way. So you may escape. You may escape from severe electric shock. Got the point? These are all application for your day-to-day life. Okay? So what happens if the earth wire is connected? If the earth wire is connected here, the other end will go to the earth, and by mistake, if there is current coming, suppose the wire is touching on the metal surface and insulation is melted and current is coming to the thick outer metallic covering, that time if earth wire is connected to the metallic surface and if we are using 3-pin plug, the current immediately will go through this one to the earth. And since in this path resistance is very less, current will go to very high value. That time the fuse will melt or the circuit breaker will switch off, and immediately the entire circuit will be switched off. So you will escape from that. So there are double precautions by using earth wire here. Okay, we will come to the details of that when we are explaining about fuse. And one more thing, the same is the things happening in all electrical heating device. Only the designing will be different. If it is a geyser, if it is a toaster or sandwich maker, any of these devices, the main part will be a heating element, a nichrome wire, and just pass current through that, you will get heated up. Now the third application is very important, that is, next application is this one, electrical fuse. See, this is the electrical fuse. Nowadays, buildings and all, we are not using this electrical fuse. Instead of this electrical fuse, we are using what is called circuit breaker. Now what is the use of fuse actually? Electrical fuse means it is an alloy. Electrical fuse wire is an alloy made up of tin and lead. Sometimes if it is electrical fuse wire used for high power supply and all, along with the tin and lead, we can mix aluminum and copper also. So aluminum, copper, tin and lead all will be mixed together. But for normal low power device and all, we use fuse with the tin and lead only. And this alloy has the main property of this alloy of tin and lead is that it has very low melting point. Melting point is very less. So when a high current passes through the fuse wire, it will melt because of the heating, Joule's heating. Now you can see here, this is a fuse This is also fuse wire. You can see inside the glass there is a thin wire. There is a thin wire inside the glass that is made up of tin and lead. It is having very low melting point, and this fuse is used for individual device. Individual device means like TV, oven, and sound systems and all. You can see at the 3-pin plug of the sound system or the oven and all. Okay, this is the 3-pin plug. Backside, if you open, there is a fuse inside this one. Suppose we are connecting live wire to one end, then current from this will flow to the device, and after flowing through the heating element, then it will come through the neutral wire, and in between that, the fuse wire is connected in series. This is the fuse. This is the one, and this is the one you can see in the picture. Okay, this fuse you are seeing in this picture, this one. Now see here, in our building there will be many lines will be there. 5 ampere line itself, many will be there. So if you remove one fuse, one section electricity will be switched off. So for different sections in our building there will be different fuses. Instead of this fuse, now we are using this one. This is the new distribution board of the building. There are many circuit breakers. These are all circuit breakers. Instead of fuse we use circuit breaker. This is the circuit breaker. Actually it is a magnetic switch. It is a magnetic switch. Inside there is an electromagnet. Okay. If it is a circuit breaker of 5 ampere, circuit breakers are more precise, okay, more accurate than the fuses. But here what happens, inside there is an electromagnet. If it is a 5 ampere circuit breaker, when the current flows more than 5 ampere inside this circuit breaker, the electromagnet becomes very strong, and it will pull the circuit, it will pull the switch downward. It will pull it downward because of the strong electromagnet, and it will switch off automatically. If the current is still flowing more than 5 ampere, then if you go and switch on, it won't remain switched on, it will come down, it will always come down, because always the magnet will be powerful to pull it down. You cannot switch it on again until you correct the circuit. If there is any mistake in the circuit, suppose in this line, so the lines are given like this. In this line, if there is any short circuits, and if current is flowing more than 5 ampere, suppose the current is flowing more than 5 ampere, the current I is going above 5 ampere, it is MCB, magnetic circuit breaker. So if the current is flowing more than 5 ampere means 5.01 is enough. Very small increase itself, it will switch off. Very accurate. A slight increase in the current in the circuit, it will switch off. Because the magnet become very strong, it will pull the switch downward. Then if you correct the circuit, if you repair the damage in the circuit, if you correct the mistake in the circuit, then only you can switch it on. Otherwise it will be always in switch off condition. So it is more protection, more safety for the circuit. Circuit breaker gives more safety in the circuit if there is excess current flowing the circuit. Okay. Now what are the reasons? What are the reasons for excess current flowing in a circuit? We were talking about current flowing more than 5 ampere, more than 15 ampere. When the current is flowing more than the allowed value, okay, the circuit breaker must switch off, the fuse must burn. So how the current goes above this limit, allowed limit? There are two reasons for that. The current flowing through a circuit, it goes above the allowed limit or the current rating of the circuit. There are two reasons for that. The one reason is called short circuiting. The second one is overloading. Short circuiting means for each circuit, I told you there are two standard of wiring. One is 5 ampere line, other one is 10 ampere line. Suppose we have 5 ampere line, switchboard is here. See, suppose this bulb is working here, and there is a live wire here, neutral wire here. Between this live wire and neutral wire, suppose 220 volt is the potential difference given, 220 volt. Say it is a 220 volt line, 220 volt line. And imagine this filament, the resistance of this filament is, for example, it is a 100 ohm. Suppose 100 ohm is the resistance of the bulb, means resistance of the filament, R equal to 100 ohm. And it is connected in a 5 ampere line, means maximum current allowed is 5 ampere. So when you switch on this circuit, a current flow through this live wire and through the filament and it will flow through the neutral. It will go back to the circuit through the neutral. This is the normal path of current when you switch on a device. When you switch on, suppose switch will be connected here. In live line always we have to connect the switch. When you switch on this one, current will flow through this way, through the high resistance tungsten filament. then it will flow to the neutral. And during this time, the resistance of this filament made up of tungsten, suppose it has a resistance of 100 ohm, just an example only, 100 ohm. Then what will be the current flowing? I is equal to what?
V by R.
I is equal to V by R. I is equal to V by R. Here what is the voltage? Potential difference. 220 volt. 220 volt divided by. What is the resistance of this filament? 100 ohm. Then if you divide this one, what will be the current? 2.2 ampere. So in this circuit, maximum allowed current is 5 ampere. Now when you switch on the bulb, the current flowing is only 2.2 ampere. Is there any danger in this?
No, sir.
No problem. So the bulb will start glowing. There is no problem in the circuit. The current is within the limit. The current rating of the circuit is 5 ampere. It is not going above 5 ampere. It is 2.2 ampere only. Got it?
Yes, sir.
Now, suppose instead of connecting through the bulb, because here the bulb is having a filament is having high resistance. And I told you before in the previous class, any device, any electrical device, if you take, there will be some internal resistance. There is no device without resistance. If there is a device with zero resistance, that means it will be short circuiting, the entire thing will burn. All devices will have an internal resistance. There is no device without internal resistance. And high power device will have low internal resistance, and low power device will have high internal resistance. Now, suppose instead of giving connection like this 2-wire connection like this to the bulb, I disconnected here. Before we have given connection to the filament, through the filament current was flowing. Now what I am doing here, I am simply taking 2 wires, one live wire from this and neutral wire from the plug, and simply connecting them together without any resistance, just joining like this. Say this end is from, one end is from live, other is from neutral. I am just touching like this. When I touch like this, what is the resistance in between? If it is one is live wire, other is neutral wire, if I am making them direct contact, then there is no resistance. We cannot say zero resistance. If it is zero resistance, current will go to infinity. If current is infinity, means then the earth will start burning. But we can say there will be a small resistance because of the loose contact. And for the material of the wire, there can be very small resistance. Suppose some 0.001 ohm resistance is there. So when we connect like this, in this area, suppose the resistance is very less, almost 0.001 ohm is the resistance. Then what will be the current in the circuit now, right now? When the current flows this way without any device, 2 live wire and neutral wire are coming in direct contact, then current flowing I is equal to V by R. What is V here? V is always 220.
220.
The supply voltage is provided by the electricity department. It can be 220 or 110. If these two are coming in direct contact, potential difference is voltage is 220 volt itself, and the resistance is here only 0.001 ohm. 0.001 ohm. Then what will be the current? There are 3 decimal position here, 1, 2, 3. So I should add 3 zeros in the above, isn't it? 2,20,000 ampere is the current. When you touch these 2 points together, the current flowing is 2,20,000 ampere. When it is 2,20,000 ampere, what will happen? Heating effect, heat energy produced, I square RT. Heat energy produced by Joule's law is I square RT. Then how much will be the heat energy produced? 2,20,000 is the ampere. 2,20,000 square of that. Then before writing R and T, it will start burning, isn't it? 2,20,000 square means very huge amount of heat energy. So what will happen if there is live wire and neutral coming to direct contact? Through the circuit wiring, the current will flow very high value because of the low resistance. You can see from the Ohm's law equation, if resistance is very low, current will be very high. And because of that very high current, the entire circuit will start burning. Along with that, the painting, the building, entire building will start burning. You might have read in the newspaper and all, the building burned because of the hyper part burned because of the short circuit. That is one reason for excess current in a circuit. The current flowing above the allowed limit is called short circuiting. Short circuiting. short circuiting. The second one is overloading. Overloading means suppose we have a circuit, a switchboard is there, and it is a 5 ampere line. Maximum allowed current is 5 ampere. From this switchboard, an extension wire. From the plug, you are taking an extension wire. Many plugs are there. This one plug, another plug here, another plug here. Many are there. So what you are doing? This is a 5 ampere line, and potential difference applied is 220 volt. It is 220 volt line, 220 volt, and current allowed is maximum 5 ampere. If 5 ampere is the current rating means maximum current allowed. If 5 ampere is the current rating and 220 volt is the line, then what will be the maximum power allowed in the circuit? Maximum power allowed in the branch will be P equal to V into equation for power is what? We have three equations for power. The first equation is what? Power P equal to V into I. Power P is equal to V into I. Okay? So if it is 220 volt line, V is equal to 220 volt. V is equal to 220 volt into current is maximum current allowed is 5 ampere. Because the fuse wire is 5 ampere, more than 5 ampere cannot flow through that. Then how much will come this one? Power, maximum allowed power 1100 watts, isn't it?
Yes, sir.
So in this line, these are 5 ampere line. In this fuse, maximum current allowed is 5 ampere. Means in this branch, in that particular branch, when you switch on all the devices, if you switch on the fan, bulb, everything in that line, the maximum current flowing should be only 5 ampere. Means the maximum power should be only 1100 watts. So in a branch, when you add the power of the fan in that line, and you add the power of the bulb and all other devices, and when you switch on all the devices, the total power of all the devices should not exceed what? 1100 watts. If it exceeds above 1100 watts, then current will go to above that, more than 5 ampere. Suppose what you are doing, you are taking connection from this extension cord wire. From this, suppose first plug you are connecting an iron box. At this point you are connecting an iron box. Okay, and from this you are connecting to a TV. Suppose the iron box is 1000 watts. What is the maximum power allowed here? Only 1100 watts. Then you are connecting to a TV. Suppose the TV is 100 watts. 100 watts. And here you are giving another connection to a device. Suppose it is a sound system, so say about 50 watts, like this. And when you switch on all of this, what will happen? Total power become 100, 1000, 1000 plus 100, 1100 plus 50, 1150. That is only on from the plug. And also inside the room you might have using the fan, bulb, etc. All this will be added up. Then in the total line, how much will be the current flowing? If the power is above 1100 watts, then current I is equal to what? P by V. Current I is equal to P divided by power divided by voltage. Voltage is 220 always. Power goes above 1100 watts, then current will go above 5 ampere. Means if you are connecting too many devices in the same line, when the power exceeds the allowed power rating, this is a power rating of 5 ampere line. In 5 ampere line, you can use maximum 1100 watts only. If you connect more than 1100 watts, then current also will go above 5 ampere. That time, the fuse wire must melt. In this fuse wire should melt and it will break the circuit, or the circuit breaker should switch off. Overloading means connecting too many devices. Connecting too many devices in the same line so that the total power exceed the maximum allowed power or power rating of the circuit. The total power exceeds the maximum allowed power or power rating of the circuit. That is called overloading.
Sir, if it is 1100 watt, then what will happen?
Exactly 1100 watts means 5 ampere. Normally the fuse wire it will not be exactly 5 ampere. It can take little more than 5 ampere. But if the current is going very high value, suddenly it will melt. But the circuit breakers are more accurate. They will not allow to take more than 5 ampere. If it is going very small excess current itself, it will switch off. That you can see in new wiring system. If there is very small mistake in the circuit, immediately circuit will switch off. Because these circuit breakers are more accurate. So these are the main reasons for flow of excess current in a circuit. One is short circuiting, other one is overloading. And one more point, suppose you have to use, suppose you are right now, this is your bedroom, okay? This is your bedroom, this is the wiring of your bedroom. And in this room, and suppose in your room some polishing work is going on. Okay, they are polishing the marble, and the polishing machine is of power 2000 watts. Can you plug that 2000 watts machine here in the plug here?
No,
Can
sir.
you use? No, because maximum allowed power is here only how much? 1100 watts only.
100 watts.
So you cannot plug a high power device like a polishing machine or any other device. It takes more than 1100 watts, should not be plugged here. If you plugged here, that is overloading. What will happen? When you switch on, current will be more than 5 ampere, the fuse will melt or circuit breaker will switch off. In such situation, suppose you want to polish the room, the flooring you want to polish it, and you want to use this 2000 watts machine. Where can you connect that machine? At which point you will connect that machine? Okay.
No.
Can you connect here in any of this line? Can you connect any of this line, this area, here or here, anywhere? These are all branches. These all branches are 5 ampere, 5 ampere. You cannot connect anywhere. You have to go to the main switchboard here. You have to go to the main switchboard here. And here you can see a main switch is there. See the main switch. Okay. In this main switch, the main two live wire and neutral wire will be there. You have to give the connection in the main live wire and neutral wire, the main one. And then it is branched into many branches for different branches. Don't give branches here, here like this area. Give to the main line. The main line, how much power you can consume? The main line, the main area here, you can consume, you can take power equal to the total power of all devices in your building. You add the power of all the refrigerator, the washing machine, AC, 3 AC, add all the power of the bulbs, fan, everything. The total power in your building. How much total power comes? That much you can take from here. And how much current it will be more than 15 ampere. It can take more than 15 ampere. All lines together. So if you want to use a high power device, the connection should be given here. Not in a branch, not in a branch. Branch can take maximum 5 ampere. And if it is high power line, 15 ampere. If you want to take more than a device with more than 15, if you want to use a device which need more than 15 ampere current, the connection should be given to the main line. At the main switch, the main live wire and neutral wire you have to give the connection, not at the branches. Got it?
Yes, sir.
So these are the main applications of the heating effect.